Okay, in this video, we like to answer 3 questions. First, what are exact equations? Second, how do we identify them? The third one is, for given exact equations, how do we solve them? Okay. Now, let's look at the first question. For given equation in this form, let's say equation 1. For given equation in this form, if there exists a function phi x, and function phi is depending on 2 variables, such that partial phi respect to x give you m xy, okay, and the partial phi respect to y equal to n. If this is true, then we call equation 1 exact equations. Okay, let me say that again. For given equation in this form, like equation 1, if you can find a function phi such that partial phi partial x respect to x equal to m, and partial phi respect to y give you n, then we say this equation is exact. Okay. Now let's look at the example. Okay, so we have equation like this: 2x plus y squared plus 2xy y prime equal to 0. Okay. We'll give an equation called this equation 2. Okay. This equation, I can tell you, is not linear and also is not separable. Okay. However, this equation is exact because we can find the phi. Okay. It's not hard to see. The phi is equal to x squared plus xy squared. Okay. You can check that. So for this equation, m here is 2x plus y squared, and n here is 2xy. Okay. So now let's check that. Partial phi respect to x. Okay. For the partial derivative respect to x, you treat y as a constant. Therefore, they give you 2x, treat y as a constant, give you y squared. Okay. So that's exactly give you m. And the partial phi respect to y, then you treat x as a constant. So give you 2xy, which exact is n. So we can say, by the definition, equation 2 is exact. Okay. Okay. For the exact equation, since partial f partial x equal to m, and the partial phi respect to y give you n, then equation 2 can be written like this. Because my m here can be written as a partial phi respect to x, and n here can be written partial phi respect to y prime. So equation 2 can be written like this. Okay. Alright, so this one can be written as d phi dx. Okay. The reason for that, because my phi here depends on x and y, and the y here really is a function of x. So using the chain rule, so phi really depends only on x. Okay. So use the chain rule in the Cal 3. So you take the derivative of the first one, then dx give you 1, then take the derivative of a second variable, y, then take the derivative of y again, give you y prime. So, therefore, equation 2 here, if this equation is exact, then equation 2 really can be written like this. d phi dx equal to 0. Okay. What that means? That means phi must be a constant, right? Phi xy, which for this case is x squared plus xy squared equal to constant. Okay. And in fact, this is our solution. Okay. We got two kind of function. One is you solve for y. One is like this one. We'll call this function implicit function. Okay. In fact, this one you can solve for y like this. You can say xy squared equal to c minus x squared. Then you can solve for y there, and which is the solution. Okay. So now let's answer our second question. If I give you equation, how do you know this given equation is exact? Okay. In fact, we have a very simple way to check that. Okay. So if I give you equation 1 here, how do you know this one is exact? What do you need to do? You check this. Partial m if partial m respect to y equal to partial n respect to x, then equation 1 is exact. Okay. Now let's use the example. Use this example as the example. Let's check. Okay. So for the equation 2, m equal to 2x plus y squared, right? So therefore partial m respect to y give you 2y. Okay. Then partial n respect to x. My n is here. Okay. Respect to x, you treat y as a constant. Give you also 2y. So that equal. That's why this one is exact. Okay, so we'll answer the second question. If for given equation 1, what do you need to do? So first of all, you have to write your equation in the form like equation 1. Then identify right m and right n. Right m and right n here. Okay. Then find the partial m respect to y. Then find the partial n respect to x. See that equal. If that equal, then we say they are exact. Otherwise, not exact. Okay, now let's answer our third question. For given exact equation, how do we solve it? Now, let's look at this example. Let's review this. Example, let's call this example 1. Okay. Example 1 is exact, right? Because partial m respect to y and the partial n respect to x are equal. Okay. So for the exact equation, like example 1, how do we solve it? Exact equation means there must exist a phi there, such that partial phi partial x equal to m, partial phi respect to y give you m. Find such a phi. Then set phi equal to constant, like here. Set phi equal to constant, then that's our solution. Okay, now let's do that for the general exact equation. Okay, now say we'll have this equation, right? M xy plus n xy y prime equals 0. Still call that equation 1. Okay. So this equation is exact. Okay. So what that means? That means it must exist a phi there, such that this one give you m and the partial phi respect to y give you n. If equation is exact, then this is true. Okay. So what do we mean partial phi respect x equal to m? That means, okay, we can find such a phi. What do we need to do? Integrate this one on both sides. respect to x. So left hand side give you phi. The right hand side give you m dx plus, normally is a constant. However, here we're talking about a partial derivative. Okay, for this is not simply constant. Any function of y will satisfy this equation, because if you take partial derivative on this equation, they will give you the one you are looking for, because this one you take partial derivative with respect to x, they will give you 0. Okay, so we need to find the c of y, which is the only function dependent on y. We can find such one by using our second condition. Okay, what is the second condition? So from this equation, we take a partial derivative with respect to y. Plus c prime y. That one must equal to, look at here, partial phi with respect to y must equal to n. So from this equation, we can solve our c prime y is equal to n subtract partial respect to partial derivative of this one respect to y. Okay, so then c of y we integrate on both sides respect to y. So you have n here, subtract respect to y. So finally, we can solve our y here, our phi here. What is our phi? Our phi here is equal to integral m dx, okay, plus c of y. Okay, c of y here is the integral n subtract partial derivative with respect to x on m dx. This whole thing is integral about y. Okay, so that's our, using this formula here, I call equation 3. Using formula 3 there, you can find your phi. Then set phi equal to constant. That's our solution for this, for the exact equation. Okay. Now let's look at the example. Okay. Example 2. How do we use the equation 3 to solve an exact equation? This equation is like this: y over x plus 4x plus ln x minus 3 y prime equal to 0. So I claim this equation is exact. Okay. So what do we need to do? Identify right m. M here is y over x plus 4x, and n here is ln x minus 3. So this equation is exact or not. What we need to check is partial m with respect to y, which give you, okay, when you take a partial derivative of m with respect to y, you treat x as a constant. So the first one give you 1 over x. This one, you treat x as a constant, give you 0. Okay. Then partial n, partial x. Okay, this time you treat y as a constant. Okay. So first one give you 1 over x, then 3 you take derivative, give you 0. So obviously that equal, right? Equal to partial n, partial x. So this equation is exact. Okay. So how do we solve the exact equation? Here is the formula. Okay. So first of all, we need to find the phi. To find the phi, we need to integrate this one and integrate this one. We need to do 2 integration. Okay. Now let's find this one first. M dx this one is m here is y over x plus 4x, right? Okay. dx. Okay, this integration is about x. That's very important. You treat y as a constant. Okay. So therefore, you integrate the first term, you treat y as a constant. Give you y ln x. Okay. Then plus 4x, you integrate it, give you 2x squared. Okay. So next let's find this. Okay. Let's find n minus, okay. Next one, let's find partial derivative with respect to x on this m dx. So we already find the integral of m dx give you y ln x plus 2x squared. Okay. So which give you this one with respect to x. Okay. Wait. Here respect to y, I'm sorry about that. Okay. Respect to y. Okay. Now let's look at it here. It's respect to y. Okay. So this one respect to y, you treat x as a constant. Okay. Treat x as a constant. So simple to give you ln x. Okay. Take the derivative with respect to y. So this term give you 0. So finally we can find our phi xy using equation 3. The first one is integral m dx, which is equal to y ln x plus 2x squared. Then plus integral. Put an n here. N is ln x minus 3. Then minus this one, partial minus this one, okay, which we find out is ln x. Then this integral is about y. That's very important. Okay, so let's simplify this. Give you y ln x plus 2x squared. Then ln x cancel with ln x. Give you minus 3 dy. Okay. So give you y ln x plus 2x squared minus 3y. Okay. So that's our phi xy. Okay. So our solution is this one. So y ln x plus 2x squared minus 3y equal to constant. This will be our solution, which is the implicit function of x of y. Okay, now let's summarize this. If I give you equation, like example 2, I give you exact equation. Okay, I give you equation like example 2. What do you need to do? Identify, write this equation in the form of equation 1. Identify right m and right n. Then find the partial m respect to y. Find the partial n respect to x. See that equal. If that equal means that exact. Okay. Exact, then we need to use the equation 3 here to find the phi. Okay. To find the phi, you need to integrate two integrals. Okay. Those integrals, one is respect to x, one is respect to y. Okay. So you need to find those terms. For this one, the first integral, you integrate m respect to x. Here, you treat y as a constant. Okay. So we got this one. Then you need to integrate the second one. Okay. You need to integrate the second one, and you need to find this term. So we find the partial, this function respect to y. Okay. So we find out is ln x. Then you substitute everything in the equation 3. we find our m. We find our phi. Set phi equal to constant. That's the solution for this exact equation. Okay. So we answer all the questions. First of all, what is the exact equation? To do that, you have to write your equation in the form of equation 1. Then find the partial m respect to x, respect to y, and find partial n respect to x. See that equal. If they're equal, then this equation is exact. For the exact equation, to solve that, you need to find the phi, equation 3. Okay. Find the phi by integrating two integrals. Once you find the phi, you have to set equal to constant. Then you got implicit function, which is your solution.